We are members of Group 5 giving our final presentation on the project of City of Orillia optimization of bus routes. These are the group members, Ratan being the team leader, Richie being the developer, and myself being the business analyst. So for project description, we are optimizing existing bus routes in city of Orillia to enhance the efficiency and reduce commute time on city public transport system. The objective is to apply data analysis and ML algorithms to optimize city bus routes. The key requirements are to access the data from right authorities, iterative testing and validation to improve accuracy and robustness of the system. In the project management practice and procedures, we have four phases: requirement phase, design phase, development phase, and testing. Requirement, we went through project charter, proposal, and collection. Design phase, we went to cleaning, database management, and EDA. In development, we plotted points on ArcGIS, allotted K-means clustering as an algorithm, and used early data analysis. In the testing phase, we used performance testing. The project progress, you can see that the idle burn down time is pretty similar to the planned hours. As the weeks progress, the total hours were 92, and as week 9 reaches, we were able to complete. The tools used were Jupyter Notebook for EDA and Python for ML algorithms, SQL for database management, ArcGIS for geospatial analysis, and MS Excel for descriptive statistics. The design phase, we were data cleaning for cleaning of monthly and hourly data of passenger count, database management to create the SQL database, and EDA to derive heat maps and hourly analysis of monthly and passenger data. You can see the monthly passenger count here for Georgian route. And this is the hourly passenger count for the same route, Georgian route. We did data cleaning for passenger count for monthly data on Georgian route. We did the same for all the other routes here. And cleaning of Lackley hourly data. This is data cleaning for hourly data for Lackley. On the left hand side, you can see the unclean, and right hand side, you can see the data cleaning hourly data for all the routes. We created SQL database, uploaded monthly and hourly database data sets, and which includes a total of 14 tables. We did EDA on hourly data for Georgian route as well as other routes. You can see on the right hand side after doing EDA, we had the results. This is for all the other routes. After completing descriptive statistics, we can see the values which were standing out, which were highlighted. That is South B, the mean value and the maximum value for South B as well as Westridge via cold water. And after doing descriptive statistics, all the data, you can see the mean, minimum, and maximum for all the routes. On the key interpretations, two of these routes stand out, Georgian route and Westridge via cold water, which have the highest ridership. So a high ridership means a wide range of variation, and which indicates that we need to have critical importance to them and stabilize usage with moderate variability. You can see heat maps for hourly data for Georgian route, and for the rest of the routes, Lackley North, Westridge via cold water, South A, South B. And this further explanation will be done by will be done by Richie.
Thank you, Google. So I'll explain about descriptive statistics of monthly passenger count. So this is the passenger count for Georgian route. As you can see, the left side is the code and right side is the table. And this is the descriptive statistics for the rest of the routes. And this is the overall descriptive statistics of all the routes. You can see all the routes mentioned here and highlighted the main points. And this is the graph of the descriptive statistics for all the routes, starting from North, Lackley, South A, South B, Georgian, and Westridge. So the main key interpretations from this graph is that we can see the Westridge via Coldwater has the highest average count, then South B has the lowest average count, and WR Coldwater as well as the North have high variability, and South B is having less variability. And also we can see that South B has the lowest body point, and the most highest route is the Westridge via Coldwater, and the least used is the South B. And this is the monthly passenger data for, heat map for Georgian route. The left side is the code and the right side is the heat map. And for all the routes, West Ridgeway, Coldwater, Lackley, and Barry route, South A and South B. And now talking about development phase, we had mainly three phases, three parts, plotting in ArcGIS, then route optimization using k-means clustering, and optimization using hourly data. So this is the ArcGIS. So here we have plotted all the bus stops with the stop name and stop number, and along with the latitude and longitude. And so first, the first part of the optimization algorithm is k-means clustering. So this is a popular clustering method. So we can see the left side is a code for the k-means clustering that has been applied upon Georgian route. And then the next step was calculating the centroid for each of the clusters that is created. That is seen on the right side. And also we plotted the visualized using the map. So you can see the bus stop locations, as well as in the second part, we can see the calculating the centroid. So Georgian road had total number of bus stops around 35. So we decided to cut off 30%. So we're taking only 70% of the total. So we got 25 clusters. So then we plotted for the, this is the plotted on the ArcGIS. We can see the left side is the original one and the right side is the optimized one. So talking about the distance covered and the time, we can see it's 19 minutes and the waiting time was 11 minutes in the original one. Then after optimizing, we have reduced the time by 18 minutes and the waiting time is only 7.7 minutes. So the total duration is 25.7. So this is for the north route, the similar thing, k-means clustering and the calculating the centroid. And also 29 was the original bus stop count, and after reducing it was 20 clusters. So we can see the similarly for north route, the original map on the ArcGIS and the optimized one. And we can see total time was 15 minutes, the same, but we reduced the waiting time. Then the time duration was been reduced to 25.5 minutes. And this is for South A, clustering and the calculating centroid. Total bus stop count was 41. We reduced it to 29 stops. And plotting on ArcGIS, we can see the total time 22 minutes. We reduced 21 minutes. And the waiting time we reduced. And so in total, like time duration was only 26.6 minutes. And for South B, total number of stops was 30 and we reduced it to 21. And we can see the total time for South B is 90 minutes, but we reduced the waiting time and it was 10.7 and total duration is 26.7. Now, Ritin will carry on with the rest of the presentation.
Yeah, thank you, Richie. So I'll continue with West Ridgeway Coldwater. So you can see the bus stop locations and the cluster for West Ridgeway Coldwater. So there were 23 routes. So now only 17 clusters. And then you can see the comparison between original and optimized. So here we are reducing the time in waiting time. We calculate it 8 minutes and then after that it is 5.6 minutes. So here we are reducing the time up to 27.6 from 30 minutes. This is similarly for West Ridgeway Old Berry route, all the clusters and then centered points. So we have total 19 stops because from total 28 stops. So this is the original and this is optimized for West Ridgeway Old Berry. So earlier time to cover distance was 22 minutes and we have reduced up to 21 minutes. Waiting time also reduced up to 5.6 minutes. So now total is 26.6 minutes. Similarly for Lackley. So Lackley also we are reducing the time in covering the distance by 1 minute and in waiting time. So now total duration is up to 26.3 minutes for Lackley. So now we have done the analysis for hourly data as well. So you can on the left side you can see the monthly average passenger count for all the routes starting from 6 a.m. to 10 p.m. So and we run the code to find out the busiest and least busy routes as well as time. So as you can see, the West Ridgeway Coldwater is busiest and South Beach is least busy. And busiest time is 3 p.m. and least busy is 10 p.m. We have plotted all the data on heat maps to visualize visualize how busy the routes are. So you can see the most of the routes are busy around 3 to 4 p.m. And you can see the Georgian and West Ridgeway cold water are most busy routes, and South and South B are least busy routes. So we can make like key recommendations from this heat maps is like we can increase the frequency of buses in between 3 to 5 p.m. and we can put some bus routes like for likely South and South B on hourly service after 8 o'clock. And then we verified our result with the using inertia method. So as you can see left side, you can see the code to verify the result with the inertia method. So there are a lot of metrics, but we use inertia method as in terms of clustering of bus routes. So as you can see, the inertia can be calculated by distance between each data point and it's centered, then squaring the distance and summing the squares across one cluster. So if the inertia value is low and number of clusters are less, then the model is good. So we calculated the inertia value for all the routes using this code. So as you can see, for all the routes, the value is very lower, like around 10 raised to minus 5 to 10 raised to minus 6. So we can tell that like the defined centered points and clusters are accurate and well defined. And if I talk about the hours, then this is a comparison between budgeted hours and actual hours for starting from requirement phase to tasting phase. And this is the comparison for budget and the actual cost. So it is lower than planned. And as I talk about the challenges, starting from week 1 to week 8, we faced different challenges, starting from like limited access to data set. Then we had issues with upload for database selection, database management selection. Then we to decide the ML algorithm method. Then plotting the all the bus stops in ArcGIS was challenging for us. And then we need to modify the algorithm as it works for all the routes. Then K clustering method changes, and at the end we need to decide upon the testing method. So as a conclusion, I can say that as you can see all the results, we have minimal of 8% reduction of time for total duration of the route. And as you saw the low inertia values, that indicates that we have defined very well for clusters. And for hourly analysis, as I explained, like it is busy during 3 to 5 and least busy after 8 p.m. So we can improve the bus service during this hours, and we can reduce after 8 p.m. So I'll show the live demo for hourly analysis. So as you can see, we have plotted I'll show the demo for okay, I'll show for ArcGIS first. So as I explained, like we have plotted all the bus stops here. And then if I show the code for our K-means clustering, and this is for West Ridgeway cold water. So you can see the points and the centered points for West Ridgeway cold water. And then this is for West Ridgeway Old Berry, all the locations and all the clusters. And this is for Lackley, like all the bus stop locations and all the clusters. So we plotted this centered points in the ArcGIS. So as you can see, this is for West Ridge, this is original, and this is after clustering, the final result. Similarly for West Ridge by Old Berry, and before and after, this is after. So as you can see, we have reduced the time. And if I talk about the hourly data analysis, then as I explained, like we calculate the monthly passenger count, and then we decided which routes busy and which is least busy, and this is the heat map. Now Richie will talk about the rest of the route.
Thank you, Rhythm. So I'll talk about the optimization code for Georgian route. So this is the program code for the Georgian route. You can see the clusters and the cluster points. Similarly, for the north route, South A, um, then for South B. And for testing, we have used inertia method. As you can see, we have calculated the performance of k-means for each of the routes. and we got the inertia values for all the routes. Now I'll talk about the ArcGIS plotting. So here we can see this is the north route, and this is the original one, and this is the optimized one, and we have plotted all the values. Then for the Georgian route, and this is the complete map, and this is the optimized map, and here is for South A route. You can see the time and the distance. This is the original one, and this is the optimized one, and this is the South B. This is the original one, and these are the optimized. So these are the applications we have done. Thank you.